Video is a review of the Edgenuity lesson, Graphing Radical Functions. So on our equation here, remember they talk about at the very beginning, the most basic radical functions, square root functions, and cube root functions. So that's the parent function, and what that means is that's the most basic one. It has no other numbers in there. There are no shifts or anything like that. This equation here helps us figure out what our shifts are. So they work the same way. So it doesn't matter whether it's a square root function or a cube root function. These properties hold true for both of them. So A, that's your number in the front. If it's negative, that means you have a reflection. So like on the square root graph, I'm just going to do a sketch here. Instead of opening up like that, you would open down. So it would be a reflection over the x-axis. If the absolute value of A is greater than 1, so that just means we're not looking at the negative part anymore. It's a stretch, so it makes it taller. So if this was like a 4 in front, it might be up here now. So it gets taller. If it's less than 1, so like a half, a third, 0.75, it's a shrink, and it makes it shorter. It brings it closer to the x-axis there. H, that's the number that's inside the radical with x. It's in charge of moving your graph left or right, and it's kind of like the opposite. So if it's a positive, x plus 4, this would be an example of moving to the left 4. If it was x minus 12, you would go to the right 12. For k, that's the number outside the radical. It's in charge of moving up or down. So if it's exactly what you think. If it's a plus 5, you're going to go up 5. It's a minus 7, you're going to move it down 7. So for this first example, we're going to describe the shifts of this graph. So there's no number in front, there's no a, so we don't have to worry about that. Underneath the radical, it says x plus 1, so that means we're going to go to the left 1. And outside the radical, we have this minus 3, so that's what k is. K is minus 3, which means we're going to go down 3. Okay, now let's look at a graph. Okay, so on this one, we have a number in front of our radical. It's 3 times the square root of x minus 2 plus 1. It's positive, so there's no reflection, but there is going to be a stretch. So to visualize what's going to happen, what I'm first going to do is I'm going to graph the parent function, y equals the square root of x, which they do in the Edgenuity video. So the 3 points that I'm going to do are 0, 0, because the square root of 0 is 0. Square root of 1 is 1, and the square root of 4 is 2. And I chose to jump to 4 because these two values here, if you square root 2 and you square root 3, you're going to get a decimal. So this is the parent function for our graph. So the first thing I want to do is I want to see how this 3 affects it. And so what it does, it's 3 times our parent function. So it's 3 times as tall. It's going to make it taller. So if my original points, like I said, were 0, 0, 1, 1, and 4, 2, nothing is going to happen to the x-coordinate because the x-coordinate isn't in charge of making things taller or shorter. We have to multiply the y-coordinate by 3 to get it 3 times as tall. So again, all the x-coordinates don't change. Now the y-coordinates, I want them to be 3 times as tall. 0 times 3, still 0. 1 times 3 is 3. 2 times 3 is 6. Okay, so now our points are, this one didn't go anywhere. This one is now 1, 3, and this one is now 4. 1, 2, 3, 4, 5, 6. Okay, I'm still going to dash it though, because that's not my end graph. Okay, now we've taken care of our stretch here, the 3 in the front, but now let's look at the other shifts. And if you were in school doing the curriculum like we normally do, I would tell you at this point we would write the book. So we had the stretch of 3. Now underneath the square root symbol, we have x minus 2, so opposite of the inside, we're going to go to the right 2, exactly the outside. up 1. So all 3 of these points that I've made taller, I'm going to go right 2, up 1, right 2, up 1, right 2, up 1. And then I do the final answer solid there. Okay, so now let's do a cube root graph. And for our parent function, the 3 points that I'm going to plot are 0, 0. So this is just the most basic cube root function, the original parent function with no shifts. And then I'm going to shift this graph using these values there. So when I draw this in, I always go from the middle out. So I make like the square root function and then kind of a backwards square root function to get the cube root function. Okay, so now there is no number in the front, so we don't have to worry about stretching, shrinking, or reflecting. Opposite of the inside means I'm going to go left 3. Exactly the outside means I'm going to go down 2. So all 3 of these points are going to go left 1, 2, 3, down 2, left 1, 2, 3. Whoa, whoops, 1, 2, 3, down 2, and 1, 2, 3, down 2. And again, start from the middle, like so.